Alright, hello, my name is Ashraf Hijab, which is Arabic for the most honorable headscarf. Today I'm going to be just jumping and showing you what my current focus is, and it's real-time across devices. And I'm going to explain what that is in a second, but a bit about my history. That's my Twitter account. You can follow it at your own peril. I do post random stuff. Been working 7 years in the mainly games industry. I worked with publishers like Activision, Vivendi, and Codemasters. Worked on games like Brian Lara International Cricket, 50 Cent, Love on the Stand, and F1 2010, which actually won a BAFTA, so that's very, very good. Spent the last 3 years working in mobile R&D, working on mobile games and cross-platform technologies, and now I'm working on Player. And I'll just jump in with the current problem that we're trying to solve. So right now there's so much opportunities happening, there's so many different ecosystems. This pie of mobile phones is growing every day. Now obviously iOS and Android are running the show, but like Firefox is pushing the boundaries forwards. There's Tizen coming out, which is a venture between Intel and Samsung, and they're currently offering, I think, a $1 million competition for HTML5 games and apps, and the contest is still running right now, and there's 2 weeks left. So if you can mock something up, potentially you can win some money. This Sailfish, I can never pronounce that correctly, but that's there's an offshoot of this technology called Migo. It used to be incubated by Nokia previously, if anyone heard of QT and stuff like that. There's BlackBerry, could be dead. There's Ubuntu, it's growing. Problem is, everyone has their own unique APIs to need to cater for. And the other problem is, the devices that use these platforms are different. They have different screen sizes, they have different screen densities, different aspect ratios. Now, about 10 years ago, our hero, Steve Jobs, he announced at WWDC 2003 something called Zero Link. And that concept was, in order to write a bit of code, what you need to do, you need to compile it, you need to link it, you need to deploy it on a device, and then you need to run it, see what's happening, and then you go to the correct screen and then replay the bug. If there's a bug there, you need to debug it, then stop it, compile it, read through it, and that's a lot of wasted iteration time. With Zero Link, they cut out the link times, which used to take minutes to do, so they sped up deployment to devices. Now there's even more problems. When you're updating your application, like, you need to, firstly, when you're coding, now you've released some apps on the App Store yourself, now you've got some Android apps. So whenever you want to do some coding and you want to test it on a device, how long does that process take? But also to get it on the App Stores also takes time. On Google Play, it takes about at least a day for it to propagate through their servers. On Apple, they have a review process that takes between a week to 2 weeks around, and they can reject you along that. But the biggest concern is users, they don't accept the updates straight away. So if you have a new update, users won't accept it straight away. Traditionally, it takes around 3 months for them to accept it. People just have all these update notifications that are just resident there. Now, Google have tried to encourage users to accept the updates by changing their policy, but again, it's still new. Now, you have a good case because you're a one-man team developing an Android application. Well, when you work in teams, I guess a few of you do have experience working with teams, you have these iteration loops between designers and developers, where a designer comes up with a design spec, hands it to a programmer, the programmer implements it, shows it to the designer, and just like that wasted time, it spins around and keeps on going. That's even more wasted time. And once you're happy with your application or with your game, you want to test it with real users to get feedback. Now there's ways to use a test. You can invite some people around to your office, to your studio, to play test it with you. You take the feedback, you change it a bit longer, and then you can publish it to the App Store, then people can actually play with it. And then depending on the feedbacks you get, or maybe some analytics that you're running inside the game yourself, you can figure out, okay, I need to tweak these levels a bit and change these things. But again, to make those changes requires you to iterate to the devices yourselves, be happy with it, and then push it to the stores and potentially wait another 3 months to get a new testable version onto the store. And lady over here, she's studying 3ds Max, and making 3D animation, making 3D content is hard. I mean, the amount of technical knowledge that you need to be good at it, it's very, very high. And then creating multiplayer servers. Has anyone here made any multiplayer systems or chat rooms, something like that before? Okay, so you agree that it's hard, right? Yeah. I guess scaling to international users is hard. But in general, making games is hard. So the vision of the project that we're working on at the moment is to have just one code base. The updates are instant, so it deploys to the devices and for the app stores instantly. It's a simple drag and drop UI and it's collaborative, so people can jump in and share. Yeah, okay, I'll show you guys a demo. I'm just going to jump into this game called World of Fighters. And it runs on iOS, Android, Windows Phone, and the web, and I'll explain how it works. And it's also open source, so you guys can actually see how the code works underneath it as well if you want to do this thing. But the idea is you can in real time update the applications to a published app. So this is a web version that I'm showing you, but it also runs on iOS and Android and Windows Phone. And here, hopefully, if this is correct, I'm gonna move. Yeah, so I can like move the assets around and drag it and drop using a visual interface, and I can also change the artwork. Let's just break it in a really bad way. But the idea is any of the changes that I'm making is in real time being propagated on these mobile devices, cutting out the iteration loops. And what's even cool about this stuff is that it's all based in a language called JavaScript. So, and the editor also runs across JavaScript. So if I go into the actual source code, and if I start hacking around the code, now I'm just going to be doing it blindly because but as soon as I hit save, it's actually updated the editor and it's updated the clients running on the phone. So it's not like some data-driven XML kind of interface, it's actually source code that's being changed. So also as an added CMS tool, you can also jump in the level in kind of like map overload view and see the characters moving in real time. And you can also mess with your players or rapidly prototype your games by moving objects around, changing the 3D models and animations, all in real time. So this character, I can drag and drop in an FBX or OBJ file into the editor, and it will upload it to the server, convert it into an open format like JSON, and once it's finished uploaded, it will actually download it onto the clients. So here I've uploaded a chest, just give it its texture, and I'm going to accept that change, and it's just converted it on the clients into the actual asset. Now again, this source code can be updated in real time, and there is some game template packs that are provided. For example, this one is a royalty-free open source game pack. It's still in beta, but the idea is you have your own kind of like fighting game that you get the source codes and the assets with it, and you can start your games based on that. Now I'm going to come back to this, and I'm going to ask you guys to ask me any aspect on how it works. Like for example, how do you throw a punch, and how do you synchronize that across multiplayer servers? Or how do you handle movement of the characters? And these are the questions that I'm feeding you, but you can ask me and I'll actually go into the source code and show you. But I'm going to stop this demo for now. As I said, this stuff that I've showed you is open source, and I think software is poetry/multi, and it's got the Android, iOS, and Windows Phone, and you can use it if you ever want to do cross-platform or learn it yourself, because it's a really good thing to write your own engine, just if you want to learn that use case. But if you want to make a game, it's best to use a pre-existing engine, like for example Unity. That's a really, really popular one to go with if you want to make something. But if you want to learn, maybe like impress your future employers with your CV, you can say, hey, this is my source code, I've looked into this area, I've done some stuff that translates this stuff. So the way this stuff supports all these platforms at the same time is it uses a hybrid architecture. And what that means is, on a high level, JavaScript is the application logic, and JavaScript is kind of like ActionScript, or a very, very high level language. And the good thing about JavaScript is that it's high level and it's highly editable. You can actually get the JavaScript parser to reinterpret source code on the fly. So you can create a new function, plug it in real time, deploy that function in the source code. The bad thing about JavaScript is it doesn't run fast on mobile phones. If anyone here has heard of HTML5, technology around HTML5 is great. You've got some really good APIs, for example, WebGL, you've got now WebRTC. Has anyone heard of those two libraries before, APIs? Okay, well what WebGL is just a web graphics library. It allows you to, within the context of the high level of JavaScript, to talk to the 3D graphics card. So if writing JavaScript source code is slow, you can actually bypass that and talk directly to the graphics card, and that way you can create some really fast 3D applications. What WebRTC is, has anyone heard of UDP, TCP, those kind of networking? Okay, so the thing about, there's some technology called WebSockets, and that what allows you to do is do real-time communications between client-server applications. And the way it does that is it gives you a TCP protocol, which means that the packets, the messages that you send will propagate through the network in order. Now there's an even faster technology called UDP, which is unordered, but a lot of games use this because it's like about 10 times faster than TCP on a high level, just comparison. So people use UDP for really high intense action games, but they put a lot of application logic to handle all the mixed messages. The easiest way to do that is they timestamp their messages and they ignore all the old messages that come along, but then they handle resubmitting the game logic. Now this might be a bit high level, the way I'm talking to if you're new to it, but we'll come to it. The idea is going back to JavaScript application logic, but it runs slow on mobiles. So what hybrid application does is it's a mix between native and JavaScript. It allows you to write JavaScript on a high level, and anything that's slow can be called in C++. So for example, if you're doing any collisions or any maps or any graphics cards, libraries, or any APIs that aren't supported by mobiles, for example, saving to the SD card, you can use the native wrappers for that. Now, applying that technology with server-side, this is something that we tried out, I think last year at Velocity Europe. It's a conference by O'Reilly who presented this use case. Is if you want to make a game that works on both the web and native, you need to use two technologies. You need to use C++ networking, like for example sockets, like using a socket API to TCP or UDP, but a C++ library to talk to, just say, like a Java server, which will then propagate the messages to other native clients. And if you want to use web app, because you can't use the C++ code, you got to use WebSockets or long polling or flash sockets or another technology. So what you can do is you can have a proxy where, for example, you have one server which acts as a proxy, and it just propagates those messages onto the main server. And that main server will contain a database provider and the connection to the clients. So what we tried out, I think about a year ago, was we have a web app on the left here, and this is your application logic in the web app. And on the right is a native app, and this is, again, the exact same game rewritten in C++. And we took the networking logic, the logic that says, hey, what happens when a player gets hit? Or hey, what happens when a player moves? Or hey, let's talk to this specific server. We took all those function calls and we just used the JavaScript code. And we wrote a C++ layer that pushes the C++ code into JavaScript calls, which calls the JavaScript libraries. And that way we have one server stack. Now, this is a bit intense. I'll show you how this all works in the real world, but I'm just going to finish off the hybrid use case story for you, because it is a bit complicated and it is a bit mental if you're looking at it from the first time, especially maybe if you're a bit new, but it is kind of like the cutting edge of mobile development. So people like Facebook have tried to use it and they failed miserably, but they had those big article in the press saying that they don't like HTML5 at the moment because it runs too slow and they switch completely to native. People like LinkedIn though, they say 95% of their code base is HTML5 and 5% of it runs native, and that's where they get the performance. But it's a big topic right now. So the way we use the hybrid application is, on the left you have your JavaScript application which has basic scripting mechanics, like for example, this scene, this screen, when you click on the button here, will launch this screen. And AI will spawn here, and the camera will point looking in this direction. But let's just say we want to draw something. So you make a WebGL draw call, like for example, draw a square. That, instead of it making the WebGL function call, it will call a JavaScript proxy renderer, and all that does is it converts the WebGL call string, will then be outputted inside a hidden web view inside a mobile application. the C++ code will pick up that string and say, hey, draw square, let me do it in C++. So then you have your framework C++ layer, and all that does is that has a high level abstraction layer between OpenGL and Direct3D. Now Direct3D and OpenGL, they're two graphics libraries. One's by Microsoft and PCs and Windows Phone, and one's on all the other phones, iOS and Android, and all the new ones. So depending on the platform, the device layer you're on, it will call the Android specific OpenGL calls, or the iOS specific OpenGL calls, or the Windows Phone version will convert OpenGL into Direct3D. So there's a library that's very popular on the internet. It's called socket.io. Has anyone heard of it? Okay, we got one guy that's heard of it. Now on the left side is the code that runs on the server. This guy. Can you guys see okay? Or maybe if I close, okay. And on the right side is the code that runs on the client. And all this application does at the moment is, has anyone here heard of Node.js?
Yeah.
Okay, we got Node.js. It's really great and it's really new. It started getting really adopted about a year ago. Now big guys like Microsoft are using it, Skype are using it. For example, if you look for a job at Skype and they've got a beautiful new London office, one of their requirements, they have an R&D role, and it's purely just hack on Node.js, and they're actually trying to use it. My friend recently got a job there, and he's just purely playing with Node.js. So it's a very, very popular technology. Everyone's pretty much using it. It's still a bit cutting edge. Traditionally, servers in languages like PHP, Python, Ruby, but now Node.js is the latest hipster trend as of last year. Now all Node.js does is it grabs the V8 JavaScript engine and it runs it on a web server, just a server. So what you can do is you can actually run JavaScript to handle your server-side logic. The great thing about having JavaScript is because the battle of the web, JavaScript is kind of won. If you want to do a web app, you need to use JavaScript. Now there is some competing methodologies coming along, like Google, Chrome, they're trying to introduce C++ using their NDK, and there are some big companies that signed on to use C++ in a web browser, but it's still unproven. But the number one language on the web, every single web app uses it, is JavaScript. And there is even newer developments. I think anyone heard of asim.js? It's a new technology pushed by Mozilla, and what that does is it converts C++ into a middle layer of JavaScript, which is insanely fast. So you can actually have JavaScript that runs really fast inside the browser now. Because all your code now is written in JavaScript in the browser, you can actually share the source code from a client-side app in a server app. So all your string verification functions, all your special library calls can just have one big code base, and client and server can share a lot of that. You don't need to rewrite it again in C++ and have the maintenance of doing that. So that's what Node.js is. And I'll give you an example of this running in. But on the left, it's a really simple library. And socket.io, what's great about it is it provides fallbacks for you if you don't have the fastest connection. Now it doesn't actually support WebRTC, which is the UDP use case of really fast communication, but it does support WebSockets, which is good enough if you guys are starting hacks, and it's more supported than WebRTC. For example, no mobile phone supports WebRTC, but mobile phones support it over Wi-Fi. Over 3G, you're going to have connectivity problems, and all it is, on the top, you just say require socket.io, you give it a port to listen on, and then the first message is connection. So whenever someone goes to that port, 8080, that's the one I've called it, you're going to receive a connection message with a socket object. In this example, which I copied off the main page, it just emits a key code called news with a JSON packet called hello world. So I'll show you that in action. But Chrome DevTools is just an IDE for debugging a web application. So to launch it, you press Alt-Command-J, or you go into the tools section and type in JavaScript developer tools or JavaScript console. Good thing about that is any messages that you print via console.log gets printed inside this stack. So right now it's telling me that there's a compile error, IO is not defined. Now the reason why that is happening is because when I go to the server localhost 8080, it doesn't exist. Now the reason why it doesn't exist is because the server isn't actually running. So I'm gonna go to my Node.js console. I'm just gonna type in node dummy server.js. So now it says socket IO started. So now when I refresh this page, it's gonna work, and it's gonna give me some debug logic over here. It says some stuff like client has been authorized, handset authorized. It's got this, it's connected over WebSockets, and it's wrote out to it news hello world. Now if I look inside the console, I get an object called hello world. Now what I'm going to show you here is I've got a button here called click me. Every single time I click on that button, it's going to send my data to the server. So check this out. Over in the client side, there's a script tag, and that's what defines where the JavaScript gets pushed inside the HTML page. It's connecting to localhost 8080. 8080 is the port that I defined my server to be. When it receives a news task, it will just console log, print out that data. But I've got this function, I've called it emit. And all I do is I emit an event called my other event, and I push my data to it. And I've got this HTML tag called the button, and I've just put on click, call the emit function. So that's why every single time I click on click me, my data is printed out on the server. Now, how do we use these tools to create a multiplayer game? Does anyone have a suggestion? We've got a way now for a client to talk to a server. Now, previously I showed you that you can use this to develop mobile multiplayer games via hybrid architecture. You can use this out of the box right now to create a web game or a web app. So we can use this for mobiles, we can use this for web, and now with these tiny lines of code, we've got a way to talk to a server and a server to talk to us. How are we going to make a two-player game out of that? Does anyone have a suggestion? It's okay, just easy answers, let's think. So we got a way from me to talk to a server and a server to talk to me. How are we going to have a multiplayer game?
For the server.
So yeah, for the server, what are we going to do?
So server gets our data and it displays that our data to the other player.
Perfect, that's it. That's exactly it. That's good, Does everyone get that? It's so simple, and like seriously, just with these awesome APIs and libraries, you can like straight away write a multiplayer game from it. So step number one, I'm just going to create var, I'm going to call it players. And I've now made a players array, right? So I'm going to put players.push socket. So now, whenever someone connects to this server, he's going to go into the players array, right? So now, in my other news event, let's just call it shoot. Let's call it shoot. And my other event, let's call that shoot here as well. So what's going to happen in that shoot message? Go on, what are we going to put in this shoot message? So when one player shoots, you said send it to all the other players. How are we going to do that? Exactly, yeah, that's it. So all it is just a for loop, or we're just going to iterate through the players array that we just made and send that message to all the players. I'm just going to make this bigger. Let's see. So plus I. Dot init, and let's just call it news. Hello. Shoot. Okay, I've just saved this. There's some lines over here. I think it's just doing some really stupid things like, hey, you got mixed lines and spaces. But in theory, when I receive a shoot message, I'm just going to iterate through the player's array and emit a news. Let's just keep it as news for, let's just for now, just in case we'll see what happens. So all I'm going to do now, I'm going to go inside this Node server. I'm going to stop it. I'm going to click Node, run it again. So now it's running with the new JavaScript logic. I'm going to refresh this web page. I'm going to click here. I'm still getting my data here. But what the key test is, if I launch this page in another browser, we should have two players now. So in theory, if I launch the console window of this, as soon as I hit click, he's also receiving the shoot message. And we can make this more dramatic. We can, rather than just saying console.data, we can just say alert. Alert, I've been shot. And one more thing you want to do is, you want to say shoot, and then if player's I is not the guy who just made that shoot message, send it to the other player. I'm just going to wrap that up, run it again. In theory, when I refresh this, so he's been shot because he received the news message. He's been shot because he's woken up. But now, when I click on this guy's received I've been shot. And the way you can tell that is that the focus of the window changes. This guy receives I've been shot. So you got a way now from one guy to send a message to another guy. Now how do we do all of the other crazy stuff? It's very simple, and I'll just show it to you straight away. Rather than me sending a message saying hello shoot, I can actually send data. So this guy sends the data, and that data is my data over here. So rather than sending data as my message, I'm going to say, I'm just going to get the time. And rather than sending back shoot, I'm going to send back the data that I'm sending. So one user is going to send the current time, the other user is going to receive the current time. So I'm going to save that. Hopefully it will work. I mean, we're just doing this live. See what will happen. So rather than me saying I've been shot, also I print out on the console the data. Now there's a function called JSON.stringify, and what that does is it converts JSON data or a JSON object into a string. So I'm just going to change that. Say that. So it says hello world first, and then it says mine, and it just gives the current time. Mine, and it gives the current time. Now fast forward 5 minutes later or 10 minutes later, instead of me passing the time, I can pass my current position. Instead of me passing the time, I can pass in the person that I'm shooting at. It can just be a simple basic chat room. So now you guys, you can just grab this source code. I think it's online. I'll send you an email if you have it or if you don't have it. But if you go to Socket.io, you get the basic version without this extra stuff. But you've got a way now to get a web app that will just multiplayer. So you want to make Civilization multiplayer. It's so simple, right? And it's out of the box. It's really, really great. So I'm going to show you exactly how to create a server. And you can now, to create a server, you can use your own PC. You can run Node on your own PC. And if you've got an IP address that isn't blocked by a firewall, like usually university IPs aren't blocked, so you can use that. Or you can use Amazon EC2 or Microsoft Azure. Now, if you've never done that before, I'll just jump in and show you how it works. So I'm going to log into my EC2 account. Linux pretty much looks like this when you're using it as a server. And I'm just going to go inside. So it looks like this, and you get some commands like cd ... and cd tools, and that just means entering directories. But all you'll do is, with Amazon EC2 is, you'll log into Amazon EC2 using an SSH key, or like a username and password. And once you've done that, you'll be presented with this terminal window. And from that, you can use this function called npm install. And what that does is it installs Node for you. And there's a guide that will give you step by step how to either install it via Git or install it using apt-get. And that will just install Node.js, the runtime on your Linux computer. Now, once you have a Linux runtime running on your computer, here this file is called dummyserver.js. Dummyserver.js right at the top there. Now, to run that JavaScript file, all you do is you type in node dummy type in node and that file name. As soon as you type node in that file name, it starts running it. Now this one says there's an error, it's in use. So that's probably because I'm already running it on that port. So if I'm running on a different port, like 8081, it says socket IO started. So once it's started now, it's running on your Amazon EC2 server. And it's running, the good thing about Amazon EC2, it gives you a virtual IP address. So if you get your web app, point it to that virtual IP address with, rather than me using localhost 8080, I'd use my Amazon EC2 virtual IP address, port, whatever port you give it, 8081, and that's it, you're now talking to a real server. The good thing about Amazon EC2 is they have a free tier that gives you free access for a year. And if you are hosting a large-scale multiplayer game, it will be a bit too intense for it. But if you're just prototyping and you want to play it with your friends just to get the idea up and running, you can get it for free. So if you're going to start using a bigger scale system, you're going to have to start paying for maybe a small server or a micro server. Micro server is around £50 a year. A small server, which gives you 1.5 gigabytes RAM and a lot more connectivity, is about 500 to 1,000 players, unoptimized. That's about £50 a month. But really, you can write that stuff down. Really, you only need to scale once you have players. Once you have players, that's a good problem to scale. Like that's fun as well. And then you can start thinking about how to distribute my nodes worldwide. So we're getting players because we're running our servers on Amazon. We're getting players from all over the world. And at first, we only had one server, and it was just in the UK. So latency times was horrible for people in Japan. China is impossible, I'll talk about that later, but it's really slow in America. So what you're gonna have to do is, to get around that is, this previous proxying system that I showed you in this page, it's actually pretty common when playing international games. What happens is, if you're in America, you talk to your American server, and as soon as you send a message to the American server, he pings that message straight to the European server or the master server. And if you're in Japan, you talk to the Japan server, and he pings a message to the main master server. And because you're all running on that network, it avoids a user on like Edge or 3G or a really slow network in Japan pinging through his crappy infrastructure to Europe. So you can actually get a really fast game with people, international players, playing in the same gaming environment just by proxying the servers. And the good thing about Amazon EC2, you can put in mechanic, and obviously now you will have to delve into their technology probably for about a month or two to get to this level of experience. I mean, they think you can do it in a couple of days, but really just to get your head around it, it'll probably take you a couple of months. But to get up and running, it's just a Linux server to play around with. If you want to go production level, full scale, it'll probably take you 6 months to get to the end there. But you can then start using advanced algorithms or just basic stats. So you can actually, in Linux, you can spin off new servers. So depending on how many users are playing your game right now, you can have it spin off a new server in this country and then spin down, like turn it off where people aren't using it anymore. So you're paying a variable rate depending on your users. And hopefully you want to be monetizing your users with in-app purchases or advertisements. So the more people that are playing, the more money you're potentially making. So now the thing is with starting nodes, dummy server, if I close this terminal window or exit out of my session, it's also going to kill that process with it. So there's a simple tool. It's called NoHTTP, and all that does is it just keeps it running as a service. You run that, you can exit out of terminal, and it will still run it in the background. But it's kind of like it's just purely a political strategy. So the way I found out about this was because I was working with France Telecom and they had a deal with them. But pretty much everyone I talk to just knows about iOS, Android, a bit about Windows Phone, maybe a bit about BlackBerry. No one knows about Tizen. But again, you can make money from this. Or at the very least, you can actually make a name for yourself in the Intel, Samsung circles because they're begging for developers. So if you just show that you can, and there's some cool stuff like, again, I don't have the instruments, I can't show you. Intel, they're crazy, they're on their R&D. They're doing, you guys heard of Kinect, right? Kinect is a 3D depth camera. So Intel are coming out with their own 3D depth camera. It's called perceptual computing. And I think they're giving £25,000 to a UK company to just prototype their idea. And they recently had a competition for $100,000 for just ideas around 3D cameras. But the good thing about Intel is they're actually going to be putting it inside their specs for their new Ultrabooks. So from mid-2014, all Ultrabooks are going to have 3D cameras built in. So you can actually like wave your hand or create a 3D model out of your face using this stuff. Again, no one knows about this. So if you get in with those circles, you can get jobs if you want to go work for those companies. They're looking for people to build this stuff up. Or you can just be in the know. So just check it out. It's a good time to be a technologist. So much opportunities. Like in Firefox OS, they're giving away free phones for anyone who just has an app idea. And you just have to promise to release it. And these apps are just HTML5. If you can get running in Chrome, you can run it on a Firefox OS device, although it's kind of slower. I like Firefox, they're good. After using the hybrid engine, we lost about 50% CPU time. So we were getting about 6 milliseconds. I can't show you the game honestly, because actually pretend it was that fighting game. We were getting about 6 milliseconds of CPU usage. When we switched to JavaScript, the hybrid engine, we're getting about 12 milliseconds CPU usage. The great thing is though, the key metric that you want to look at is GPU usage. And in order to get 60 frames a second, you need to be hitting 16 milliseconds. So right there on that screen, we're not getting to hit 60 milliseconds, but our bottleneck is the GPU. So we could afford to lose 12 milliseconds of CPU time, and it still won't affect our frame rate whatsoever. So unless you're doing really complicated physics that you can't push on to the GPU to do, then like CPU can be wasted on application logic and stuff like that. Whereas the GPU, that's really the killer. If anyone plays with fast scroll and you get a little chug on Androids and stuff, it's because it's loading the graphics inside and outside of the memory on the GPUs and it's really slowing it down. And obviously Java is very, very challenging when it comes with the garbage collector. So we're going to talk a bit about going into 3D. And we're going to talk about movement and collision detection. Now, does anyone here have a laptop? Or you can actually follow through this. Okay, we don't have to, it's fine. You guys just want to knowledge. So WebGL is exactly the same as OpenGL ES2. OpenGL ES2 is the graphics library that runs on iOS and Android. So it's pretty much a complete copy of the spec, but it means you can run it in the web and you can run it in on mobile devices inside a web browser. The only difference is it's using a different language. So whereas in OpenGL on Android, you can use C++ or Java, and even the Java in Android actually calls C++ underneath the hood. And inside iOS, you can use Objective-C or C++. Inside WebGL, exact same code, but the syntax is different, it's just in JavaScript. Good thing about WebGL right now is it's actually supported by pretty much everywhere. It's even supported in the new Internet Explorer 11. So on the new Windows Phone devices, you can actually push a WebGL application and it can run inside the browser there. It runs really, really extremely well on BlackBerry. Again, it runs on Tizen, it runs on Firefox OS, although the devices there are really slow. It's going to run the new Ubuntu. It actually runs right now on iOS, but they've specifically limited it to iAds, so you can only use it in adverts. Potentially they might open it up for apps. On Android, it runs in the newer models of the phone. Sometimes you need to enable a flag, or sometimes you need to use a different browser. It does run on the latest devices, but it's going to be part of their ecosystem very soon. And again, Chrome, it runs really well. Now, has anyone done any graphics programming before? Everything in 3D graphics is a triangle. And there's 4 things you're going to hear about it. Now, there's something called vertices, UVs, indices, and normals. And all a vertex is, and I'm not going to do a good job of this because I'm probably going to end up jumping, it's just a definition of a point in space. So in this example here, we have 3 vertices. There's these coordinate systems X, Y, and Z. UVs is how the textures is mapped onto that triangle. So if you have, let's use my mouse here, if we have an image, how is the image going to be pasted on this triangle? That's where UVs come into play. So again, you just have a U and a V, which is X and Y, and you just say it's going to be the bottom right, you say it's going to be the bottom left of the image, in the middle of the image, and the graphics card will automatically interpolate the image and blitz it on top of that triangle. Indices is an optimized way for drawing triangles. Now, let's just say, in order to make this square, I'm going to have to use 2 triangles, right? So that means I need to say this point, this point, this point, this point, this point, this point. So I've repeated myself when saying these points. With indices, you can just say there's 4 points, and you just do this one, this one, this one, and then draw it this one, this one, this one. So it's just a way to index a bit of data. A normal is just a way to explain, well, it can be used in several ways. The most popular way is just a way to explain how the light reflects off a 3D object. So for example, the main normal of me is this way. So when a light hits me from different angles, it's going to shoot out in this way. So what a normal does is, it tells you which way the light will point, which way the light will refract. And when you have something called like a bump mat or lots of normals on your face, the light is going to bounce in different directions. It's a website called Learning WebGL. Now WebGL is a low-level web library for OpenGL. Now there's very high-level tools around that you don't need, that you can avoid looking at WebGL itself. Very, very popular library called Free.js. There's a really good startup in the UK called Play Canvas, building tools on top of this. Another one in Romania called Chameleon, where they do 2D kind of like stuff. And I'll go through this in the end. But if you learn WebGL, or just give a crack at learning WebGL, it's going to really just open up your mind so much to doing this stuff yourselves. And just when you use an engine or a high-level library, you're going to just be able to do things a lot more easier. What it does, it has 15 lessons, and it actually has explanations on how to do all the effects. And it starts off from 0, a black screen, to drawing a plain triangle, into drawing rendered texture. I'm going to show you the source code of these. So again, lesson 1 has a blank screen, and again, it's all open source. So you can go inside the source, and you can see what it's doing here. Like for example, here it initializes GL. If you never used Chrome DevTools before, you can put a breakpoint anywhere. So you can just put some breakpoints around here. Refresh the page, and it's going to hit the breakpoint. You can press F10 to step through the code. And you can even hack around, like I can get rid of. Okay, it won't let me. If it was a local hosted file, I can actually change the source code and save it and run that on the fly. Now lesson 2, it's great. It shows you how to draw a triangle, a color triangle. Fast forward into lesson 5, showing a textured cube spinning. Lesson 9, it's a nice beautiful particle that you can spin around and move the camera. And this is all, again, all the source code is there. And I think if we're going to draw, so draw star, for example, I've got a breakpoint there, and it's going to tell me in the call stack. So what call stack is, it shows you the functions that are occurring in its history. So first we start off in this function called tick, and it's calling draw scene. Inside draw scene, it's doing some stuff, and then it's got a for loop going through all the stars, and it calls stars.draw. Inside stars.draw, it does some matrix mathematics, and then it calls draw star. Inside draw star, it's going to do some stuff, something activate texture, so it's setting the texture, it's binding some buffers, and then it's drawing the triangle. But like the source code's there, you can just jump in. It's very accessible for anyone. And if you've got Chrome, you can debug it yourself. And if you run it off your computer, not off a web server, you can actually change the line of code. But if you run it off a web server, you can also just change it, for example, a text editor, and then refresh the page. Very, very accessible here. The last one, if you just go through these lessons one by one, you can make render to texture. So what it's doing there is drawing the scene twice. It's drawing the scene first with a sphere and a cube. It's rendering that into a buffer, and then it's drawing the second scene of a laptop, and it's referencing that buffer. All this cool stuff in WebGL now. If you combine this beautiful graphics with the tools that you've got for multiplayer gaming, you can do some really, really fancy cutting edge stuff. And Google are always looking for people who can do some really creative stuff, and they even pay small companies and digital design agencies to create beautiful visualizations to show off the power of Chrome and the web. So I'm gonna go through one of these lessons just to show you like the overall stack on how to turn it into a game. I've got this page here. Previously it would spin around, but now I've got it to go up. But when I press down, it goes down. Yeah, so it's going up and down. What I'm going to try figuring out with you guys is how to make it go left and right. So I'm going to go inside the source code of this lesson, and I'm going to break it down one by one how it works. But before I do that, I'll show you the actual main function that we want to be going into. And this is the draw scene function, but I'm just going to break it down on exactly what it does. So this is just a big garbage of code. It's become self-aware, it doesn't want to see it. It's big garbage of code. The top of that function, and it's probably hard to see, but that top block, it just sets up the view. The next 4 lines, it positions the cube and it rotates it. The next 7 lines sets the buffers. It sets what the vertices are, what the UVs are, and what shader is going to use. Now, shader is just a way to define how each pixel and each vertex is manipulated by the graphics card and drawn, but we can just avoid that for now. The last part, it tells the graphics card which texture it's going to use. Now, the last one we told it the UVs that we're going to use. It would put the texture, which is the wooden one. And the last line of code is just draw elements, and it gives it the buffers. So we're going to find this function inside the source code. Got way too many windows. Inside this source code. So I'm going to go inside sources here, index. And let's start off first one. The first function that gets called is initGL. So there's this function called onload. And onload is kind of like the first function that's going to get called inside a web app. And here we're calling WebGL start. That, it gives it a canvas object. A canvas is a HTML5 component which allows you to do graphics. You can do 2D graphics or 3D graphics. In this example, we're initializing GL to be a 3D graphics card to use 3D graphics. So here it's getting the context of experimental WebGL. Now, you guys will just have to call it WebGL. It gives it a canvas width and the height, but this is the boring part. Sets up the shaders, sets up the buffers, sets up the textures, and then it calls tick. And then nothing else seems to happen. Now, the reason why nothing else seems to happen is because inside tick, it's using this function called request animation frame. Request animation frame is a new API built into graphics card, I think about a year or 2 ago. Before, in order to do a timer event inside JavaScript, does anyone know how you used to do that?
Do you use your timer class?
Perfect, yeah. So there's a function called set timeout, and all that does is it tells JavaScript to remind you after a certain period amount of time has elapsed. Now this new API called request animation frame Now this version is called anim frame because it's cross-browser compatible. You can go into it and see what it looks like. But request animation frame, all that does is it tells the graphics card next time you're going to redraw the page, or the next time the graphics card is going to do a refresh of the display, run this function. So it's a lot more optimized than just breaking it at random points. So here we say call a function called tick, and it's actually this function itself. So it's just telling it to keep on calling itself every single time you're going to redraw the screen. So now we've got a way to redraw the screen. Sorry, turn the phone on. Perfect. And every single time that function is ticked, it's calling three functions here: handle keys, draw scene, and animate. It's calling GL viewport. That specifies the size of the view. Then it's calling GL clear. That specifies, hey, clear out the screen, because you don't want to have the previous render onto this frame. Then it's setting up this thing called perspective. And this is just a function that tells you, rather than looking at the screen as a square, give it a camera perspective view. So here we're giving it a 45-degree perspectiveness. Now we can make it 90-degree and make it look wonky. So let's do that. So let's make it 10, show you the changes happening. So all it is just increasing and decreasing the amount of perspectiveness we give it. And then there's this thing called matrices. Now, with matrices, it's nothing like Neo or Keanu Reeves or The Matrix, nothing like that. It's just a way to represent an object or a piece of space's position, scale, and orientation. And now these are just, they provide like, it's just Mat4, this is using this library called GL Matrix, and it's just a high-level API for advanced mathematical operations. So don't be scared of maths, all you need to learn is just the API calls. So it calls identity, which means 0, make this 0. Then it calls a function called translate. Translate means move. So you start off in 0, and then we're going to move it depending on the x, the variable x pos, y pos, and z. And then we're going to rotate, depending on x rop, y rop, around the x-axis and the y-axis to rotate. So just looking at this right now, and looking at this call, when I press up, he goes up, when I press down, he goes down. I can just assume right now that if I take the y pos and put it in the rotation function, so he's also rotating now, because the variable that's changing when I press up and down is also being used to modify the rotation. So if we want, just forgetting about the rest of the stuff draws some stuff, forgetting about the rest, we kind of know what we need to do if we want to make this work go left and right. Does anyone have a suggestion on how we can make it go left and right? 0, 0, and I make 0. I'm going to say this, and we're going to get nothing. I'm going to make this 0, 90, 0. Refresh this, he's gone. I'm going to make it 0.5. And he's towards up a bit. I'm going to make it 0.75. And he's up a bit more. I'm going to make them both 0.75. And now he's up a bit to the right. So in this example, we can go up and down. So now that we swap y pos and x pos, he goes right and he goes left. So that means we need to feed in the left and the right buttons into x pos. Does everyone understand that, kind of? So x pos, it's currently always 0, and y pos is a certain value, and there's a good way to debug this actually, and hopefully to make it clearer. So if we go inside the Chrome Web Tools, I'm going to refresh this, I'm going to press, he's going up. I'm going to go inside y pos, I'm going to put a breakpoint here, and I'm going to look inside my scope variables. I think it's global scope, so I'm going to not write it down. I'm going to put it in a watch window. I'm going to type in xpos, and I'm going to put in ypos. So ypos is 1, and xpos is 0. When I press down, ypos changes. So if I put breakpoint again, so that ypos is now -1, but x is 0. But when I'm pressing left and right, xpos isn't changing whatsoever. So I think we just found that there's a bug right now in this source code that is affecting xpos. So it's like if you've ever experienced a bug before, if you just jump into the debugger and start hacking things around, you can kind of like figure out. Something else you can do, which is really cool, is you can type in console.log, and then you can put in xpos, ypos. So now every single frame, it's actually going to be in the console window. It's going to be printing out the xpos and the ypos. So if I press, if I press up, you see that the ypos has changed. If I press left, xpos is still 0. So that's just a way to spit some data out and see what's going on. So we know that the problem right now is hopefully to do with xpos not being fed. So I'm going to jump into ypos. I'm going to see why is that working. And I just search for it. There's this function called animate. And animate, all that does now, it takes the current time, negates it from the previous time, and that gives you the delta frame. Has anyone heard of like game loops and delta update frames before? So I'm going to just explain how that works is. So every computer, they work on variable clock speeds. Like for example, this phone is a lot slower than this PC. So if I'm running a piece of code, this PC will run it, just say like 1,000 times faster than this phone. So this function is going to get hit 1,000 times more than when it's running on this phone. So the way we measure for that is we cater that variable time by just finding out how much time has changed since every single screen redraw. Now if it's a slow operation, and just say it takes 1 second to redraw the screen, the delta time between the last frame and this frame will be 1 second. Now if we're traveling at 5 miles per second, every single second we should have moved, let's just say 5 steps. 5 steps per second, we should have moved 5 steps. So if I'm running on a fixed algorithmic time, where every single time I tick or hit animate on one computer, I'm just going to be adding 5 every second. But on the other computer, because he's running 1,000 times faster, after 1 second he's going to be like over there. So the way we counter that, we use this thing called time deltas. What it does is it takes the previous time, takes the current time, negates the previous time, and that tells you the time difference. You times that time difference with your speed, and that's your incrementation value. So if since the last frame has been 0.001 of a second, you times that by 5, and that means you only move 0.005 every frame, which means by the time this one updates, by the time I update, this one's going to be a nice smooth animation, and this one's going to be just one big jump, but they're both going to be running on the same game logic. Like the next time you hear about like game loops or delta frames or even multiplayer servers or even jumping into Amazon, you're going to have like a good idea on like this is possible, that we can do this stuff and it's really easy. So with this code, I'm just spotting a mistake. It might be because I wrote it really badly, but it looks like that I'm just catering in for ypos and I'm not doing anything about the xpos. So I think in theory, if I just copied this code and just changed the y to an x, I think it worked. Let's find out. So I'm going to just make this x, 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 x. I'm just going to run that. I don't know, I've never tried this before. So now it goes left and right, and it goes up, and it goes down. Now if I was to debug this further, it sounds like x speed is the speed of motion of the object. So that was being changed. It was saying you're now going 5 faster than the x, but it just wasn't being added on to the xpos. So the real function that is part of this program is just xpos plus x speed and ypos. Yeah, but without those limits, it goes kind of like outside of the screen. So that's why I had it there. So I'm going to just battle on, and we're going to go into how to make this more advanced, how to actually turn this into a game. Because we kind of like have a way now to control a player. We can move him left, up, down, left, right. And there he is, he's moving around here. So how do we get 2 players on the screen? Okay, we're going to have to duplicate that one. So let's go into, let's go into this SMB, and let's continue battling on to draw scene, because we stopped at the translate, because that's where we found our things. So now, just the way that it's binding the buffers to draw, we're going to have to do this draw call twice, based on 2 different locations. What I did to do that is I created this class, or in the JavaScript world they call it functions. I called it player, and I gave it an xpos value, and I gave it a ypos value. So previously, xpos was a global variable, so there was only one of them. Here I'm associating the x and y position to an object. And then I create a player 1 object, and I create a player 2 object. So it's just new player 1, and his xbox is going to be 0, 0, and then new player, and his xbox is going to be 0, 0. And then I change player 1's xpos to -15, and I put player 2's xpos into 15. Now I think it should be 0 and it should be 1, but it seemed to have worked. So one player is now on the left and one player is on the right. Just flowing with the way this one works. So I'm going to set this to 0 and set this to 0. It's not actually in the middle, but I think the camera is kind of offset because the camera is actually larger than the screen. So it's a bigger viewport, so it actually is in the middle. See? Just, yeah? That was a trick. We're setting the viewport, we're clearing the screen, we're setting this perspective, and then we draw player 1 and draw player 2. And then inside draw player, that's where all the garbage happens. So we've just grabbed all that draw stuff, put it in a function, and we've drawn the players twice. How are we going to draw 3 players?
Create another instance of it.
Okay, good, we got that, it's good. New player. So just like new player here, I'm going to push another player. I'm going to make this guy 15. Is that all we do? Still only got 2 players in the screen. So I'm going to jump back into draw scene. And I can see that I'm just drawing each player one by one, draw player, draw player. So how would I draw the 3rd player?
Same, but just change the
array index.
the array.
Yeah,
The
or
ID.
we can have a for loop with players of length, right? So I'm going to draw that now. And now we've got 3 players. So you guys can have a Pong game right now. You can have your player go on left. That can be a ball. And the other player can move via the node server that we've got previously. Hook this stuff together and plug it in. One thing's left though that we don't know how to do. And hopefully it's here. And it's movement and it's collision detection. Now, has anyone here done any collision detection before? That's it. So if the x of one object is the same as the x of an object, something's collided. Now just say the object has a certain radius or a certain size. How do you cater for that? Okay, well, I guess you'd use some maths, or there's lots of different tools. I guess you can do a radius, distance check, that kind of stuff. The most basic way to do collision detection is just a simple 2D box check, and pretty much every single game engine uses this as its first pass of attack. It's a very incorrect way of doing advanced collisions. What it does is it puts a box around an object, and it says, does this box intersect with this box? If it does, that means it's collided. Now, more advanced game engines will use that as a first test, and then it will say, okay, let me actually check the polygons and see if it actually collides. But that way I can cater out all the objects that are around it, that are far away, and I say performance. But the most easy way to do collisions is just a box check. So I'll show you how that function works. All it does is, it checks if the right side of the box is greater than the left side of the second box. So this is left, this is right, and this is my right and my left. If the right side is less than the left side of the box, the other box, clearly I'm not colliding. But if my right side is greater than the left side of this box, that means I've potentially collided in the x-plane. So the second check I do is, is the front of me greater than the bottom of him? If it is, that means I've collided. If it isn't, then I'm not collided. So that's what all these if statements do. It's just, is my max greater than his min? Is my min less than his max? Because, just following the first time that I said it, my right side could be less than his min, and that means I'm completely on the other side of him. So that's safe. So that's why you do both sides as a check. Now, let's apply it to our source code logic. So previously we had this thing called ypos, and it was inside the animate function. And previously I do ypos plus equal the speed of the delta time. But I've added one if condition. I've said can move. And all that can move function does is, it gets my min x, my left x, my max z, my right x, my min y, my max y, and it compares it with all the other players in the map. If it's not me, because I don't want to compare with myself, if it's someone else, it gets the opponent's right, left, top, forward, and it does the exact same if check that we've seen in the screen. If it collides, it will return false. That means I can't move. And if it doesn't collide, it will return true. That means I can move. So that's why, maybe I should shrink this down a bit. That's why, when I press right, I can go past him like this, I can go past him like this. But if I collide, that's it, I'm stuck, because I can no longer move. Now what you could do yourselves is, rather than just saying, if can move equals false, don't move, you can just say, hey, this is now a bullet, and this bullet is traveling this way. As soon as it hits or collides, as soon as there's collision, explode, kill someone. You can make a really simple shooter game, and you can make one player control this guy, the other player can control the other guy. And that tool's all there for you. I think this source code, if you want to have this, yeah, look at this. You've got like a first-person shooter game you can potentially put in. Now the only difference between this guy and what we had, we were moving from the top, forward, back. He's moving from the Z. So all the collisions will still work. It's just the camera is facing here, rather than the camera being from the top. The camera is facing here. So you can still use everything else you can do. You can have another player moving around. Alright, but again, you don't need to start there. There's some really great helper libraries, free.js. Now, if you're in the world of 3ds Max, you're going to probably have to figure out how to load your OBJ FBX files yourselves. The support for web, for these kind of formats is very limited. There are some new engines that support this stuff, but learning how to do it using a web yourself is pretty limited at the moment. Again, the source code of the first project that I showed you is open source, and it has its own FBX loader and OBJ loader, so you can just steal that from there. It's a very liberal license. We talked a bit about multiplayer stuff before. I'll give you just a roundup for the server-side stuff that we did before. Now, I showed you a very easy use case for servers. What you're gonna have to do is, there's a lot of hackers in this room, I'm looking at you. You're gonna have to put in some server-side logic, just some validation, like saying if this guy is moving really fast or shooting infinite number of bullets, he's probably a hacker, or kick him off, or some sort of validation. You can't always trust the stuff coming in from the client. So just say a client says shoot, make sure you have a tally of the amount of bullets he has on the server so he doesn't abuse it. So you're gonna have to think about server-side validation. Again, load balancing, why I talked about the nodes, you need to separate it out geographically and per server. You can't just have infinite number of players connected to one server. And you have to be clever about latency. So if someone's got a really fast Wi-Fi connection and another person's got a really slow 3G or edge connection, you're gonna have to start using some prediction algorithms to figure out how the player versus player stuff is going to happen. Now, if anyone played any multiplayer racing games, what they usually do is they turn off collisions for the race. So you go through the other opponents, because racing games, they travel really fast and you need to have a really low latency to actually get a fun game. And the way they work is they're constantly interpolating. So because you're driving like 100, 200 miles per hour, your position here isn't where you really are by the time that message gets to the other player. I mean, it probably takes you 6 milliseconds to get to the other player, maybe 30 milliseconds to get to the other players. So you've lost, what was it, 60 milliseconds, maybe let's just say 25th of a frame or 25th of a second there. Now cars, they travel really fast in that amount of distance. So what they're constantly doing, they're constantly like telling the server where he is, and there's a resimulation happening in the other car racing game. So if I'm here in my universe, and I've traveled to here now in my universe, over in my opponent's universe, I'm going to be simulating going in this direction. And then I'm going to be told that, hey, I'm actually over there. So I'm just going to interpolate over here. And then I'm going to interpolate over here. It's not actually going to be a smooth, realistic resimulation of my movement. But then there's a lot of racing AI that's put inside of it that follows rather than just linear interpolations. It uses splines, it uses curves, and it uses AI mechanics. But pretty much I know that I've drawn myself here, but my server just told me that I'm actually over there. So I just have to kind of interpolate myself over there. So that's why a lot of the player versus player racer games, they turn off collisions. Because if I'm really over there, but I'm colliding with my opponent when I'm in my universe over here, to validate that collision is going to be really hard. Now they usually enable it when it gets to really low latency networks, for example LANs, if you're on a local Wi-Fi connection, or you're playing split player. If you're playing over the internet, then most games, even the last game I worked on, we just turned off collisions because it was just impossible to get the latency correct for that. Because it's just a very jarring experience when you're just 1 minute crashing into a player and then really you should be over there. Rather than just saying, I'm going to shoot a bullet in this direction, what you can do is on the client side and then on the server side you can revalidate it. We can say when a player has shot in this direction, you can shoot a line and predict where the bullet's going to go. If the bullet is going to hit a player that's here, then you can tell the server, hey, I've shot in this direction and I've hit that player. So if the server validates that that player has been hit in his simulation, he can tell the end client, the player that's been hit over here, hey, you've been hit wherever you are in your world, you're going to get hit by the player. So maybe in my universe, player one's universe, I'm here and he's over here. By the time he gets this message, he's now over here, and maybe I'm now over here. When he gets that message, rather than shooting in that direction, I'm just going to shoot at that player. So that way you still get the enjoyment factor of competing when it's completely faked collision, but that's just kind of latency hacks that people put in and prediction algorithms that people put in to avoid the whole choppiness for multiplayer games. this game's completely open source and it's available if you go to the website. And to load it in yourself, it's a zip package, and you just drag and drop it into the editor, and it will just upload little source code and assets if you don't have it or have it. And inside of that package, it has all the FBX files, so all the 3D models, all the images. So all the images and all the JavaScript files. So you can see like how it works, and you can also, like, just like I showed you how to use Chrome to debug the source code, you put breakpoints in there to have a hack around and see what's going wrong. Once it's imported, you got like a live game that can be published on iOS, Android, and all those platforms and the web. If you grab the open source code, you can also publish it on the App Store yourself because you've got an Xcode project. You can play a little multiplayer game, and you can dig around yourself, I guess, if you want to find out how it works, like if you want to be exploratory. But one of just the cool features, I think I showed it before, is purely, if I go into the source code, just increase it here. I think if I update, yeah, for example here, I'm gonna get this guy out. So as soon as I change some lines of code, so if I save, it's actually updated the source code live in real time, so I can, for example, tweak the camera angles. And if I find my opponent, like just say that intro there, get ready, and people are punching, and just say I don't like that intro. Rather than traditionally you'd stop, you'd recompile, you get to that bit of source code, I can go into the function and intro here. I can just have it constantly replay that intro, and I can just tweak it. Like for example, if I want him to kick instead of a punch, and just change that to a kick. So that guy's kick now instead. And again, this stuff is instantly deployable on phones. Now the thing with real-time technologies, it's actually being adopted in the games industry as we speak. So the new version of C++ has a feature called edit and continue, which allows you to real-time deploy C++ code changes without changing too much of the class structure on deployed devices. So you can hack it on an Xbox, you can hack it on a PC, potentially on a PS4. The new version of Unreal Engine 4 actually supports real-time code edits as well. But where it's currently limited is that it's real-time in the contents of your PC. So the next step on that, there's this drive into cloud gaming. There's this company called OnLive, and the way they worked is they had server farms playing the best games in the world, and they'd stream you a video of that game, and they guaranteed that you'd have a fast enough connection that you wouldn't notice the latency of you using the controller to talk to a PC in the cloud. So it's been tried on a very aggressive layer, having a real-time cloud, and it's now being pushed into Unreal Engine 4 and the newest games engines inside real-time deployment on a phone. The next step would be real-time and cloud pushed together. So I talked to some companies that are already interested in this kind of technology, like for example, can't say who, but like one of the biggest games companies in the world. They were telling me that using this technology would be groundbreaking for user-generated content. If you want to make a game that is long, you need to constantly yourself produce new content for it. Whereas if you had a system where you could actually update the source code, the assets in real time, and you can actually run it from any device, you've now infinitied the amount of possibilities of gameplay mechanics. So because you've you've multiplied the amount of permutations of gameplay types, of of user interactions. It means you have to create less content and the game will perpetually run itself. And there's a really good example in this from the industry. If anyone's heard of Little Big Planet or Minecraft, those games were made once and the users themselves, they're the ones who's creating all the new content for it. So this is it's a very big topic in the industry, and the other big topic is multi-screen gaming, like for example, having your console, because everyone's using your mobile phones and tablets at the moment. It's the largest growing PC base. So if you have your console game here, multi-screen experience would be when I'm on my phone, I'm also playing in that gaming universe. But the clever thing about it is you need to think very carefully about how you're going to handle that game mechanics and the link between the game, because at the moment it's unnatural to be playing on another controller or using it for other screens. Wii U, Nintendo tried the Wii U concept, in which they have a tablet gaming device in which it connects with the Wii games console, and you have maybe like an overhead view of the map inside on the Wii U, and you have the game that's being played on the screen. But these are again the new topics, which is user-generated content and multi-screen gaming. And we're gonna try figuring out how this stuff works and solving it together. I mean, the stuff that we're doing at the moment, we're trying to focus on kind of like the open source model. So we're building royalty-free open source game pack. So this is like a very, very basic example of an open source game pack where you get a finished fighting game. We're also going to be making an RTS game, a real-time strategy game, kind of like Age of Empires, World of Warcraft. We're going to give away the source code for that and the models, because a lot of people don't have to draw and some people don't have to program. So if you don't have to program, you can just use the existing program. If you know how to draw, you can just change your own models yourself. If it's the other way around, you can use the models and add in your own logic. We're making car racing games, flight simulator games. But if you check out our website, was it player.ir, PLAYIR.com, you can get a good example on what we're doing. There's a really good campaign at the moment, it's called code.org, and they're telling you that I think in the next 10 years, the demand for computer-related jobs is going to grow to 1.4 million, and there's only 400,000 people going to be currently available to fulfill the demand of jobs. And there's a really huge drive right now in mobile computers. That's the biggest emerging market right now. If you are HTML5 capable, and it's a very easy technology to master, so there should be no excuse why you can't even do some basic stuff, or even just grab the learning WebGL stuff, modify a simple thing, show it to a potential employer, look at this, what I did. That's going to be such a big topic. And I told you, people like Microsoft, Skype, they're asking for people who know JavaScript and Node.js and that kind of stuff. And if you can just be slightly ahead of the curve, like look into technologies like WebRTC. That WebRTC allows you to do peer-to-peer communication. I mean, you can set up your own torrents server if you want to be a bit aggressive about this. Right now, everyone's just using it to set up their own Skype competitor. And I know people who quit their jobs at Google to set up their own startup to try selling Skype competitor services using the power of WebRTC, because they see it as a big emerging market. It's very good getting a job in the industry or pursuing a job in the industry, but to be honest, all you're going to learn in the industry, well, a lot of the stuff you're going to learn is how to not do something well, because big companies, they hire lots of people and they have so much production overhead just to get something done. And there's so much wastage in that. I mean, in my last company, we had so many meetings, so many middle managers, just so much politics, just so much wasted time. And their mission was to commercialize R&D projects. And all it ended up doing, we'd come up with some really amazing R&D projects, but because we had to include SMS into all of them, it just wouldn't get out the door. And then you get people like WhatsApp just dominating the market, all our projects were blocked. So you have a really amazing opportunity right now, because the market is so open. You can release a website today that is a 3D multiplayer game that runs on mobile phones and the web, and you can charge people for it. There's like Go Cardless, there's Amazon payments, there's PayPal that charge for it. You can release an iOS application, get it out into the store. Okay, you might not make a lot of money because there's a lot of problems getting visibility there, but just for your portfolio, just having a basic iOS app, the fact that you went through the experience of having an Android app releases, that just 10x'd your CV. And I'm very, very serious with you. When I was doing the hiring at my last company, anyone that just hacked around at home on personal projects, they just instantly get cred. And I'll tell you the kind of interviews that we did in my last company. This might be a bit ahead of the curve, although we'll see if other people implement it. Like we tried doing failure tests, we tried doing these stupid tests that ask you about how many sewers there are in the country just by guessing the amount of citizens there are. There's like all these dumb brain teasers that we asked you, or like a die-hard question where you get like some liquid and see certain containers and you have to fill it up. But in the end, we just couldn't really resonate with the right candidates doing those tests. So what we did, we just ended up doing a practical test. We just gave them 1 hour, the Learning WebGL website. We said, just do something cool, anything. Here, look, here's the source code. And I'd come in every single 20 minutes and I just pretty much just tell them what to, like, just if you have problems, just do it. So in 1 hour, you just hack on code. Some guys, they struggled. They just had no idea what to do, and it was just a complete nightmare for them. They just didn't know where to start. Other guys who'd never touched JavaScript before, just grab code. One guy did a cover flow implementation. Another guy did some crazy camera within a camera. He just took the last example, just hacked it a bit, but it really just shows your skills, just being able to just jump in when you code. And the thing that you're going to learn is just everything is so easy if you just try. I mean, you guys are clearly smart people because you're in university, and given an infinite amount of time, you guys can do anything at all. Now these technologies, the barriers to entry is just getting lower and lower and lower. So if you just jump into even web technologies, you can create an app that runs on all these devices that can be multiplayer, and it can be cutting edge. And that's just crazy. Cutting edge using the web. I mean, web used to be like the most monolithic framework you can use, and you used to always go native. But you can actually do cutting edge stuff in the web, and you've got giants like Google who want you. You've got giants like iOS and Apple want you. And Mozilla, they want people that just have this ethos. And the competition isn't really there. Sure, there's lots of super smart guys out there, but again, going back to that code.org base point, there's going to be 1.4 million jobs requiring computer services in the next, I think, 5 or 10 years, and there's only going to be 400 people able to fill those jobs. So you guys are in demand. It's insane. Like, you guys can even, with your Android projects that you've released right now, you can even get contracting jobs for like £500 a day. I'm not joking with you. There's a website, gun.io. They're always offering, gun.io. They're always offering contracts to people. And if you've got portfolio apps, even if it's a basic web page with stuff that you've stolen from Learning WebGL, you can actually get hired and get paid for doing something that you enjoy and learn from. Sorry, I'm kind of preaching too much. But yeah, web technologies is just, everyone's kind of after that, but just make sure that it's mobile-centric web. So just make sure that, just launch the browser on your iOS device or Android device and just make sure that it still works. If it runs on a mobile phone and it's using web technologies, that's like an insane market to, everyone wants that.